Good morning, everyone. Today is Monday, November 13th. Wow, so quickly. See, we have less than a month. So today we will finish 6.4 and we start 6.5. This Wednesday, you have homework 8 and quiz 5. Okay, everybody? And then next Monday, you have homework 9 and quiz 6. Remember I told you? Because we postponed some of the homework and exam dates. So the remaining 3 weeks, you're going to be very, very busy. Okay? So, yes. All right. By the way, we have 11 homework. We dropped the 2 lowest scores. Okay, so if you finish homework 9 and if you get all the perfect scores, you don't have to submit homework 10 and homework 11. But if you want to do well on the exam, I strongly recommend you to still do those homework. Okay, everybody? Because the homework prepare you for the exam and the quizzes. Okay, so let's continue. 6.4. Last time we talked about implicit differentiation. So we use implicit differentiation if we cannot solve for y in terms of x. So this is not a function, it's a relation. Sometimes it's impossible to solve for y in terms of x. And do you remember the steps? We take both sides, take the derivative with respect to x. And you might need to use product rule or chain rule. Differentiate the x. It's like you multiply by dx, so it's like one, just regular derivative. But when you differentiate the y, you need to use chain rule. So multiply by y prime at the end, okay, after you differentiate the y. And then, so you can see some terms has y prime, some terms does not have y prime. So you move all the terms with y prime to the left-hand side. And all the terms without y prime move to the right-hand side. So your left-hand side, your y prime is a common factor, right? So factor that out, and then your y prime is your right-hand side divided by this left-hand side factor. Okay, so this is the function of x and y. So you put in that point and you can find the slope, and then you can use the point slope form to write out the tangent line, and your normal line slope is negative reciprocal. Okay, everybody? So let's do 2 more examples of this session. Okay, look at this one. This is a cardioid. Okay, it looks like a peach. Okay, so we want to find the equation of the tangent line at the point 0, 2. Do you see here 0, 2 is right here? So you're kind of looking for the tangent line passing through that point, right, everybody? And you know that point is 0, 2, so you need to find the slope at that point. Okay? So we take the derivative on both sides. So dx, x squared plus y squared minus 2x squared. We take the derivative. And on the right hand side, do you see I can distribute the 4. So I'm taking the derivative of 4x squared and 4y squared. Yes, everybody? Okay, on the left hand side. Oh, do you see it's a composite function? It's something to the square, right? So chain rule. What is the derivative of u squared? 2u. So write down the u. X squared plus y squared minus 2x times u prime, right, everybody? So every time you do chain rule, multiply by u prime at the end. Yes, everybody? On the right hand side, what is the derivative of 4x squared? Blank? Yes, ax. And how about the derivative of 4y squared? What? When you differentiate the y, what do? Yes. See? Even though it looks like, oh, both squared, but for x squared, the derivative is ax. But the y squared, you need to multiply by y prime. Okay, everybody? So let's see. Okay, we got 2 times x squared plus y squared minus 2x. And what's the derivative of this triangle factor? Well, the derivative of x squared is 2x. The derivative of y squared, 2y times. Every time you differentiate a y, you multiply by y prime. Okay, everybody? Every time you differentiate a y, the old formula times y prime. Okay? Every time you multiply by y prime when you differentiate a y. Okay, how about the derivative of negative 2x? Yes, minus 2. And then on the right hand side, we have 8x plus ay times y prime. Okay, so for the previous problems, we would try to move the terms with y prime to the left hand side and move the terms without y prime to the right hand side. But do you see this is a multiplication? And if you want to separate the terms with y prime and without y prime, well, you will need to distribute. Okay? So if you want to solve for y prime, you need to distribute and move all the terms with y prime to the left hand side and move all the terms with y prime to on the right hand side. But for this problem, because it asks us to find the tangent line, okay, it's instead of asking us to find the derivative. So we can do an easier thing is we can plug in the number here. Okay? We can plug in the number here that we will get the slope. Okay? So this will be easier than multiply everything out and then solve for y prime. You know what I'm saying, everybody? But this problem, because it does not ask us to find y prime, okay, so we can actually plug in the number, the points, so we can get the slope at that point. Okay, that will be easier than working with all these x and y. Do you agree, everybody? So for this particular problem, because it does not ask us to find the y prime, it asks us to find the slope at that point, we can plug in the points 0 to here. You see, x is 0. 0 squared is 0, right? And then y squared, 2 squared is 4, right? And minus 2 times 0 is 0, right? And then x is 0. 2 times 0 is 0. Plus 2 times 2 is 4. Y prime we don't know. Okay, and then this y prime is actually, we plug in 0, 2. So y prime is a function of x and y. And after we plug in 0, 2, this y prime is just a number. Okay, everybody? So this is a number. Okay, this is a number. How about let's call it m, okay, to make it easier. And a is x. X is what? 0, right? X is 0. 8y. What is 8y? Dylan? 16 times y prime. And then here y prime is we evaluate at that point. So that is the slope. Is that okay, everybody? Oh, let's see. We plug in, so we calculate it. So it's 2 times 4, so it's 8. And then here is 4m minus 2 equals 16m. You see, this is much easier than distribute and move the terms around and stuff and y. This is much easier to compute. Is that okay, everybody? We plug in x is 0 and y is 2. Okay. Do you see both sides? We have common factor of 8. Yeah? Let's divide it by 8. Then left-hand side, we get what? We get 4m minus 2. How about right-hand side? Page, how about right-hand side? 2. So 2m. How do we solve for m? What do we do on both sides? Add 2. And also we can subtract 2m, right? Then what do we get? I can't see. What do we get? Yes. Oh, so what is m? 1. Ooh. So nice, right? Okay, tangent line. What is the point so form, Gabby? Y minus what? What is the point? 2, yes. Equals 1 times x minus the x coordinate of the point. Yes, 0. Okay? Right? Well, we are at the point 0, 2. So the y coordinate is 2. The x coordinate is 0. Do you still remember the points of form? Y minus the y coordinates equals to the slope times x minus the x coordinates. So what do you get? Y equals x plus 2. So this is our tangent line. Yeah, looks about right? It looks like the slope is like 45 degrees. Yeah, so this is the tangent line. And remember the y-intercept is 2. Yeah, the y-intercept is 2. Okay, everybody? So this is the tangent line. Okay, so this example teaches us that sometimes if the problem does not ask you to solve for y prime, you can plug in the number first. Okay, everybody? So sometimes you plug in the number first, then it's easier to calculate the slope in that way. Okay? You don't always need to solve for y prime, then plug in a number there. You can plug in a number first and then solve for y prime. Okay, example 4. Okay, so this is the harder example. So the derivative is more complicated. Okay, let's do that. So your exam might look like this. Yeah, everybody pay attention. So we take the derivative. Okay, take the derivative. And remember when we take the derivative, well, if you see square root, change it to the standard form. Square root is x to the what power? Down J. Square root of x is x to the what power? Half. Yes. And plus ln of 3y. All right, let's see. We take the derivative. Do you see the left-hand side is a composite function? Yes, composite function. Joseph, what is the derivative of u to the 7th? 7 times u to the what power? 6. And then times u prime. Okay, so do it slowly, step by step. So this step, we use the chain rule. So u to the 7th derivative is 7 u to the 6th times u prime. Right, everybody? And then, okay, fine. What is the derivative of 5x to the 1/2? Yes, very good. Everybody okay with the power rule? Well, how about the derivative of ln of 3y? Times, see, this is like a u. It's 1 over u times u prime. Right, everybody? And actually, what is this u prime? Do you see the 3 stays here? And the y prime stay here? So in fact, the 3 cancel. Yes? This 3 is on the numerator. This 3 is in the denominator. So they cancel. We only get 1 over y times y prime. So this 3, do nothing to it. And why is that? Do you remember the ln property? ln 3y is ln 3 plus ln y. Yes, it breaks the products into sum. And then when you take the derivative, oh, do you see the derivative of constant term is 0. So this is just the same as the derivative of ln of y. Therefore, no matter this is 3 or 100 or million, does that matter? No, it just equals to the derivative of ln of y. Okay, everybody? So let's keep going. So we have 7 x to the 4th e to the 5y plus 8 to the 6. Okay, here. The derivative of 8 is 0, right, everybody? But the derivative of a product, you need to do product rule, right? Product rule. Okay. Product rule. What's that, Dylan? Yeah, first factor prime times second factor plus u prime. First factor times the second factor prime. Yes. The right hand side, we have 5 over 2 x to the minus 1/2 plus 1 over y times y prime. So far, so good, everybody? Yes, so here we use chain rule and product rule. That's why I say this problem is harder. Okay? But this is the hardest type of problem in this section. Okay? So you might have something like this in your next exam. Okay. Let's keep going. So x to the 4th e to the 5y plus 8 to the 6th. What is the derivative of x to the 4th? Page. Yeah, 4x cubed. And how about the derivative of e to the 5y? Mackenzie. Yes, 5e to the 5y, but then when you differentiate the y, you multiply by, yes, y prime, good. Okay, and then we copy the right hand side. Okay. Do you see the right hand side? Oh, I can separate that this term has no y prime and this term has y prime. But on the left hand side, well, this factor, part of the factor has no y prime and part has y prime. So you want to separate. Okay? So separate them, we want to distribute. Yes, everybody? So make sure you distribute. Okay. So distribute. You want to separate the terms with y prime and without y prime. Okay, so even though it's big factor, it's okay. Just copy it. So copy this and multiply by the first factor, 4x cubed e to the 5y plus, okay, copy this. Wow, this problem you're going to be very patient. Do it slowly because there are so many terms here. Okay, so be patient. Okay, this is the left hand side. The right hand side, don't touch it. Just copy it. Is that okay, everybody? Distribute. This factor multiplied by the first term plus this factor multiplied by the second term. Do you see we separate the terms with no y prime and this term has y prime? Okay, so terms are separated by plus or minus. Okay, this is one term and this is both terms. Okay, and then these guys are just factors of this term. Okay, so for the terms with y prime, okay, the terms with y prime is this term and this term. Yes, we want to move them to the left hand side, right? So this is already on the left hand side. Yes, we want to move this term to the left. Then what happens? The sign changed from plus to minus, right? So you let go of side, subtract this term. Yes, everybody? Okay, so move to the left. You get 7x to the 4 e to the 5y plus 8 to the 6 x to the 4 5e to the 5y times y prime. And then what? You move to the left. So what happened? Yeah, it becomes subtract. Subtract 1 over y times y prime. Okay? And how about these two terms? These two terms has no y prime. Yes? So we want to move to the right hand side. Yes? So move to the right hand side. Okay. So my right hand side is 5 over 2 x to the negative 1/2. And then what? Plus or minus? Minus that giant term. So minus 7 x to the 4 e to the 5y plus 8 to the 6 4x cubed e to the 5y. Oh, by the way, if you can combine the 7 and 4 together, yeah, that's 28, right? You can also combine the 5 and 7 together. That is 34. Sorry, 35. 35. Yes. Okay. Do you see the left-hand side? I can factor out the y prime. So I can factor out the y prime, and that equals this right-hand side. So my y prime is my right-hand side, which is 5 over 2 x to the minus 1/2 minus 7 times 4, 28, x to the 4th e to the 5y plus 8 to the 6, and then x cubed e to the 5y. Oops. Okay. Is that okay, everybody? No? So, everybody okay with this step? So we distribute. We want to separate the terms with y prime and the terms without y prime. On the right-hand side, the terms are already separated. But on the left-hand side, they're not separated. It's a product. You want to separate it. So you distribute.
Why don't you do a fraction or whatever you did the last part before you put anything in the parentheses?
Oh, okay. So we call the steps. What are the steps? So here, this is the process. We take the derivative, right? We move the terms with y prime to the left-hand side. Yes. We move the terms without y prime to the right-hand side. Yes. Next step. Factor out y prime on the left-hand side. Even though our problem, it looks the terms are so complicated, but the steps are still the same. That's why you want to separate the y prime and the terms without y prime, because all the terms on your left-hand side have a common factor y prime. So you can factor out the y prime. Then how do you solve for y prime? It's your right-hand side divided by this left-hand side factor. So this is the process. You might have a complicated problem, but this process remains the same. Okay, everybody? Yes. So that's why here we move the terms with y prime to the left-hand side. Move the terms without y prime to the right-hand side. Even though the terms are complicated, but it's okay. The process is still the same. We want to factor out y prime. Yes, everybody? We factor y prime. Then how do you solve for y prime? Your right-hand side divided by your left-hand side factor. Okay? Yes.
What do you go when you get all those numbers?
All these numbers? In the numerator? These ones? Oh, this is the right-hand side. We move the terms without y prime to the right-hand side. So, okay, which step you're at? The green one? Okay, so after we distribute, you have some terms with y prime, and you have some terms without y prime, right? So you want to move all the terms with y prime to the left-hand side. Move means both sides add or subtract some terms, right? So, are you okay with this step? This term has no y prime. You want to move to the right. How do you move to the right? Both sides subtract this term, right? So that's why I use two different colors. I use purple color for the terms with y prime. You want to move to the left. So you have this term, stay on the left-hand side. And then this term, move to the left, so you both sides subtract that. Yeah? And then this term without y prime, move to the right. How do you move it? You both sides subtract that. So this is how we get the right-hand side. Okay? How do you solve for y prime? Well then, Because all the terms on your left hand side have the y prime. You can factor out the y prime. Okay, I think I cannot be lazy. Let me actually write this down. Okay. We factor out the y prime. Yes. We factor out the y prime on the left hand side, and the right hand side is the same. And can I put the same, or do you want me to copy it down? Huh? So your left hand side, we factor out the y prime. So this is what's left. And then the right hand side is the same as this. Is that okay? The right hand side stay the same. We don't touch it. Oh, you know what? I can do this. Yes. Oops. Ah. No. Hey, I wanna copy down here. Uh-oh. Okay. My word is not responding. Okay. So, okay, here. Yes, it's the same thing. So we just copy down the same thing. And then your y prime is the right hand side and divided by this left hand side factor. Oh, yes. So this is left hand side factor. Okay. Okay, good. So this is the answer. Questions? Oh, because it's 7 times 5 is 35. And 4 times 7 is 28. So if you want to put 7 and 5, yeah, feel free to do that. You won't get points off for that. Okay, yes. So this problem, yeah, the problem is hard, but the process is the same. Okay, everybody? You differentiate both sides with respect to x. You might use product rule, chain rule, and then you want to distribute, move the terms with y prime to the left hand side, move the terms without y prime to the right hand side, and then factor out y prime on the left hand side. And then your y prime is your right hand side divided by the left hand side factor. Is that okay, everybody? So even though the numbers look so a lot of x and y and so complicated, but the idea is the same. Okay. Sometimes I ask my students, don't think about this as a very complicated thing. If I just put a plus by prime equals c plus d, what do? You want to move this to the left, so you get by prime minus dy prime, yeah? And you want to move this to the right, so you get c minus a. And then you have y prime on the left hand side, you can factor. And then your y prime is your both sides divided by b minus d. Yes, so if I just use a, b, c, d, is this more obvious to you? Yeah? But this a, b, c, d, this complicated term, just view it as a, b, c. Okay? So, okay, and then sessions. Okay, session 6.5. Related rates. Yes. So please do more exercise of implicit differentiation. Okay, related rates. So we talk about optimization problems is when you want to find the maximum or minimum. Okay, related rates is one quantity depends upon two or more quantities that are changing with time. You're talking about the rate of change, which is the d of that quantity dt. Okay, everybody? So to find the overall rate of change, you need to do the chain rule to relate all the rates of change. Okay? So the procedure is similar as before. Okay? You sketch the picture, name the variables, what is changing, give it the variable name. And what is constant? If that number is constant, don't name the variable. You give the variable only if it varies. Okay? So if some quantity is constant, just put it the number. And then write down the relations and formula. Do you remember the optimization problem when you want to find the maximums? You take the derivative with respect to that variable, either x or r. Remember everybody? The here related rates, you take the derivative with respect to time, t, rate of change, d of the quantity dt. Okay? And then substitute known values and solve for the desired quantity. And also check that units are consistent and the answer is reasonable. So if your quantity, okay, is increasing, then you know the rate is going to be positive, right? If your rate is decreasing, if your quantity is decreasing, then your rate is going to be negative. Right, everybody? So use this criterion to check whether the answer is reasonable. Do you still remember this picture? You have 2D and 3D pictures. Yeah, 2D, you're talking about the area and the perimeter. 3D pictures, you're talking about the volume and surface area. Right, everybody? Okay, so let's look at examples. So two small planes approach an airport. One flying due west at 120 miles per hour, the other flying due north at 150 miles per hour. So let's say here we have the airport, and we have one plane flying west. By the way, are you okay with this? This is the north, and then this is the east, and this is the west, this is the south. Yes, everybody? Everybody watch Google Maps? You do drive? Yes. You have car? Driver license? Okay, so we have a plane. Okay, this is like a plane. Drawing west. And 120 miles per hour. Okay, you can see 120 miles per hour. This is the velocity, right, everybody? This is velocity. And the other plane drawing due north. Okay, so we have another plane drawing due north. Okay. And the speed 150 miles per hour. Assume they fly at the same constant elevation. How fast is the distance between the planes changing? Okay, let's set variables. So for horizontal distance, let's call this is x. Okay, so this is x. Vertical distance, let's call this is the y. And then this one, let's call it the z. Z is the distance between the two planes. So this is the picture. Is that okay, everybody? All right, our goal is to find the rate, how fast is the distance between them changing. So you're looking for the rate of change of the z, the distance between the plane. So dz dt, we're looking for dz dt. When the westbound plane is 180 miles from the airport. So westbound plane is this one, right? When the x is 180 miles. So when x is 180 miles. And the northbound plane, oh, that's the y, is 225 miles. Is that okay, everybody? Okay. So this is when at the moment, you know, x and y is changing, right? Your x is decreasing, your y is decreasing, and your z is also decreasing. Do you agree, everybody? So let's figure out all the quantities. Miles per hour is the velocity, right? So from the picture, we know velocity is dx dt. And because your x is increasing or decreasing? Decreasing. So your velocity will be negative. Yeah? How about your y? Your y is increasing or decreasing? Decreasing. So your dy dt is what? Negative 150. Okay? And when we look at this problem, you know your dx dt and dy dt, these two numbers is always the same. Right, everybody? But the x and y, they are changing. It's not always equals to 180, not always equals to 295. It's just at the moment when x is 180 and y 295, they want you to find what is b, c, d.
Is it negative because
No, slowing down and speeding up is about the acceleration. It's negative because the quantity is decreasing, because your distance is decreasing. That's why it's negative. Remember?
even though the number is close to the bottom?
Yeah? Sorry?
Even though, like, you put negative for 120,
Yes.
even though the 180 and the 25
Yeah, the x is going down. So x is going down. It's just asking when the moment when x, so maybe your x was like 300, it's going down, right? It asks you at the moment when x is 180, find the rate of change of the z. So this is just at that moment. This only happens at that moment. And then this is always the speed of the westbound plane is always 120, and the speed of the northbound plane is always 150. So these two are fixed all the time. This is changing. It's just at that moment when x is that and y is that. Okay? Good. So, okay. Now, we draw this picture, and also we also change all the numbers in terms of the map symbols. And now we want to find the relations. Well, what's the relation between x, y, and z? What's the relations of the sides of a right angle triangle? With the sides. 3 sides. X squared plus. Very good. By Pythagorean theorem. Right, everybody? So here we're not asking to find any angle. It's just the relation between the 3 sides of a right angle triangle. So the Pythagorean theorem. Oh, by the way, this is my z and this is my 2. Make sure you can distinguish your z and your 2. Okay, so this is the relation. Okay, now we're gonna take the derivative with respect to time. What's the derivative of x squared with respect to time? So derivative of x squared is 2x, but times x prime, right? Which is dx dt. I know in the last session, because you were taking the derivative with respect to x, so dx is 1. But now you're not taking the derivative with respect to x. You are taking the derivative with respect to t. Okay, everybody? So all the variable after you differentiate, multiply by d of that variable to t. Okay, what's the derivative of y squared? 2y times dy dt. What's the derivative of z squared? Yes, very good. Oh, can you see all the terms have common factor 2? Right? So let's divide it by 2, make it easier. So x times dx dt plus y times dy dt equals z times dz dt. Yes, everybody? So after you differentiate, now you can plug in numbers. What is x? X. 180. What is dx dt? What is y? 225. Yes. How about dy dt? Negative 150. Okay. What is z? We know that we're looking for dz dt. That is our goal, right, everybody? That is our goal. We want to find dz dt. But what is z? Okay, we still need to figure out what is z. But at the moment, see, at the moment when x is 180, okay, when x is 180, at the moment when x is 180 and the y is 225, what is z? Do you see is by the Pythagorean theorem is the square root of 180 squared plus 225 squared. Yes, everybody, at that moment. Oh, this is our z. Our z is this. Okay, therefore, we can put the z here is the square root of 180 squared plus 225 squared and dz dt. So far, so good? How do we solve for dz dt? We want to solve for dz dt. How do you carry out this? Both sides divide. Yes, everybody? Okay, both sides divided by that. So dz dt is 180 times negative 120 plus 225 times negative 150 and all over the square root of 180 squared plus 225 squared. Okay, what do you get? Everybody take out your calculator. What do you get? Point 1? Okay, thank you. And miles per hour. Okay, everybody? And do you see it's negative? Okay. Because my x is decreasing, my y is also decreasing, then our z is also decreasing. Yes? Our z is also decreasing. That's why our dz dt is negative, which makes sense. Okay? So, again, what do we do? The first step, you draw the picture and write down all the numbers and name the variables. What is changing? What is constant? Okay? And then you translate all those into math symbols. For the speed, if the quantity is increasing, then your speed will be positive. If the quantity is decreasing, your speed will be negative. Okay? And then you find some relations about the variable. And important thing here, differentiate first, then plug in a number. Many students plug in a number and then differentiate. Well, you know what? If you plug in the number and then differentiate, do you see when you plug in the x and you plug in the y, you get constant? Then the derivative of a constant is just 0. Your rate of change is not 0. So make sure you derivative first, then plug in the number. Okay? And then at the end, yeah, figure out all the quantity, plug in all the numbers. If you cannot find that, draw some picture. Realize this is the Pythagorean theorem. And then you get the part. Okay, so yeah, do your homework. Come to ask me questions. So we only have 1 month left. Try your best. Thank you. Have a good day.